In 8.0, we spent time looking at right triangles. We solved for sides and angles by either Pythagorean theorem, SOHCAHTOA, or taking the inverse. In 8.1, we're going to take a look at a new way to compare sides and angles when we don't have a right triangle to work with. Law of sines is going to be an alternative to SOHCAHTOA. It says for any triangle ABC. Notice the angle is marked in one corner and then the side is directly across. Angle B to side B, angle C at that bottom left over to side C on the right. So we're first going to have to be able to recognize that an angle has a capital letter and a side has a lowercase letter that matches. Law of sines is just a ratio comparison of an angle to a side length. If we take sine of angle A divided by its corresponding side length, that fraction will always be equal to any of the other two pairs in the triangle. Sine angle B divided by its side length, or side angle C divided by its side length. Now when we solve, we only need two of them. So what we're going to do is just pick two that we know some information about, and then we'll cross multiply them. And that will help us solve any missing part. Now, law of sines is going to be useful when we have some specific information on our picture. So we know that we'll always be able to create one triangle if we know two angles and one side. We have to be given that information. So it can look something like this. We can know maybe angle A, angle C, and then side A. That grouping is called angle, angle, side. So the side isn't in between them. Or we actually could have two sides and an angle in between them. Maybe like angle C, angle B, and then side A in between. So if you have either of those two groupings, we know that we can create a triangle using this rule for law of sines. When asked to solve each triangle, if you're already given two angles, regardless of what other information there is, we're going to apply the triangle sum rule first. In that first triangle on the left, triangle ABC, angle A is 30, angle C is 45, and that 32 actually represents lowercase a. So I'll put a lowercase a there. The side length directly across angle B is lowercase b. And then angle C, if we go directly to that top part right there, I'm just going to draw a little c for that side length. Now, if we say to solve the triangle, we know three parts, we have to find the other three. We're given two angles and a side, so we're given angle, angle, side here. To solve, the first thing we're going to do is find that missing angle. We'll apply the triangle sum rule first. So the first thing we can calculate pretty quickly is angle B. The triangle sum rule from 8.0 was just to subtract the two angles from 180. We'll have 180 minus 30 minus 45. And that means angle B is the biggest angle in the triangle. It's 105 degrees. Just like that, we get 105. But then we need to find the two missing side lengths, little b and little c. And this is where SOHCAHTOA won't work for us. SOHCAHTOA can only be used if we have a right triangle and there isn't a 90-degree angle. So let's pick, I don't care, we need to do both. So let's pick side B first. So I'm just going to go little b. This is where we'll apply the law of sines. So on the picture, what we were given was angle A is 30, and we know that its corresponding side length was 32. This will be the sine fraction or ratio that we use to compare the other two. So sine of angle 30 over 32. It's just like that. But if we want to try to solve side length B, that's across that 105-degree angle. So again, we just need two of the three ratios, sine angle B, which is 105, over side B. And that's the proportion that we'll set up, two of those three fractions. And then I said to cross multiply. So I'm going to take little b times sine 30 and set that equal to 32 times sine 105. The nice thing about cross multiplying is we automatically get rid of the fractions. We do need to get b by itself, however, so let's go ahead and divide both sides by sine 30. Here's where the calculator is going to come in. We need to type all of this into our calculator. 32 sine 105 divided by sine 30. Go ahead and enter that in and then write down what you get. You'll round this answer to the nearest tenth. 32 sine 105 divided by sine 30 should be approximately 61.8. That would be the length of side B. So now we need to do the same thing to get side C. Clearly, I wrote way too big, so now I need to fit side C in a pretty small space. So I hope you have enough room to make this one fit. To get side C, we're going to start with the same ratio we did for B. That was our given information. We're going to take angle A divided by the side length A by doing sine 30 over 32 again. That's the same thing we did in step 2. This time though, if we're trying to find side C, angle C is 45. So we'll do sine of that angle divided by the side length. And then just like step 2, honestly, we follow the same exact process. We cross multiply. C times sine 30 equals 32 times sine 45. Gets rid of our fractions. Divide both sides by sine 30. And then we plug all of that in to our calculator. And the side length for C should be approximately 45.3. Taking a look at all 3 side lengths, remember by definition, the biggest side is always across the biggest angle. And that would be side B. B is the biggest side, and angle B was the biggest angle. And that's using law of sines to help solve for missing sides and angles in a non-right triangle. For our second triangle, ABC over on the right, this is an angle-side angle comparison. We have 2 angles and then the side in between them. In order for us to apply law of sines, the first thing we're going to do again is find that missing angle by applying the triangle sum rule. To get angle C, if we do 180 minus 35 minus 40, the strange thing about this problem is we get 105 again. So it doesn't always equal 105, but this time it will. And if you can hear my cat Diesel, he's very happily purring on my desk here while I'm doing this video. So sorry about that distraction. Now the thing about 105 is that's the only angle we can use to create a law of sine fraction because we're given side C. So we need to still solve for either A or B. Doesn't matter which one you pick. I'll pick A first. A's angle is 35, but we need to set up our initial ratio. The angle and side that we know are C, so if we take sine C, I want to change the color. I like having that stand out a little bit. There we go. We'll take sine C, which is 105, over side C, which is 10. And if we're trying to find side A, we'll set that equal to the ratio of sine 35 over A. And then you guessed it, we cross multiply. A times sine 105 equals 10 times sine 35. To get A by itself, we'll divide. And then again, you just enter it into your calculator. It's kind of nice once you get this process figured out. If you type in 10 sine 35 divided by sine 105, A is approximately 5.9. Okay, so let's apply that same rule then for B. It's our last step here. Hopefully you have enough room to write again. To get side B, notice that's opposite that 40-degree angle. Let's set up our original ratio first. The sine 105, hang on just a sec. There we go. That's what I wanted. All right, we'll do sine 105 over 10. And we'll set that equal to sine B, which is 40, over side B, which we don't know. I'm going to scroll up here now that I have that ratio written out. And then let's cross multiply one last time. And that solves this non-right triangle. B times sine 105 equals 10 times sine 40. Gets rid of our fraction. But then to get B by itself, we'll divide out that sine 105. And plug it all into your calculator. 10 times sine 40, divide that by sine 105, and we get an answer that's slightly bigger. It's approximately 6.7. So again, just verifying our work here. The biggest side, the biggest side is always opposite the biggest angle. And the C, which would be 110 degrees, and side C holds true. Side C is the biggest of the three sides. Like 8.0, when we get to the application problems, you don't have to solve for every missing part, but we may need to solve for a couple of things in order to use our law of sines ratio. It says a light pole tilts toward the sun at an angle of 8-degree angle from the vertical, and it casts a 22-foot shadow. The angle of elevation from the tip of the shadow to the top of the light pole is 43 degrees. How tall is the light pole? So ultimately we're solving for that side length A right here. If I recreate triangle ABC, notice that right angle kind of gets lost in the picture. So I've got C for the top of the light pole, angle B down here on the ground, and angle A over across the road. It says that the shadow is 22 feet, the angle of elevation is 43, and notice there's an 8-degree angle and this right degree angle. I guess green is probably not the best color there. There's an 8-degree angle and a 90-degree angle. So on our picture, that creates an angle of 98 degrees for angle B. Now the goal for us is to determine what is the length of the light pole. So that's side A opposite that 43-degree angle. If we start the idea for the process of solving using law of sines, the first thing we'll calculate is angle C. So to get angle C, we'll just do the triangle sum rule again. 180 minus 98 minus 43, making that angle 39 degrees. Now that's helpful to us because that's across the side length that was given. So if we want to find side A, we only need to do one ratio here. We don't have to solve everything. We can go ahead and set up our law of sines by taking the fraction and the side and the angle we already know. Sine 39 from angle C over side C, which is 22. We'll set that equal to sine 43 over A. So I want you to actually pause the video and do the cross multiply here. Can you get A by itself, and can you label correctly? So round to the nearest tenth and label. Once you think you have it, press play. Did you get A equals 23.8 feet? When I cross multiplied, I got A sine 39 equals 22 times sine 43. Divide both sides by that sine 49 and then plug it into your calculator. And there's an application problem using law of sines to help you solve. Last but not least, we have a formula for an area of a triangle that doesn't have that right angle. Typically, the formula for the area of a right triangle is 1/2 base times height. But if we don't have a right angle in our picture, it's harder to calculate. We have a formula using sine to help us. So the A and the B would be any two side lengths, and the angle is the angle in between them. So I'm going to put a mark on side A and a mark on side B, and then notice it's angle C. So this is a side, angle, side kind of comparison for area. Now we don't have to find any of the other missing parts. We're just going to use this information to generate the area. So it says find the area of a triangular lot containing side lengths that measure 24 and 18. So I'm going to make my A 24 and my B 18 just to kind of model this definition with an angle of 80 degrees in between. So that would be our angle C. You've got that side, angle, side kind of grouping. If we want to find the area, we're just going to write the formula K equals 1/2. All we really do, everybody, is just multiply the two sides together in any order because we're multiplying. And then we multiply that by sine of that angle in between them. And just like everything else in this lesson, plug that all in at once. And the approximate area of this non-right triangle would be 212.7 square yards. That's the thing to remember for area. We have to square our label. And that's it for lesson 8.1, day 1.